Here I'm going to graph two transformations of the base or parent function y equals square root x. That's the first thing you want to be able to identify in these transformation questions. Know what functions this could have come from. So think about the functions we've looked at, like y equals x squared, root x, x cubed, 1 over x, absolute value of x. Out of all of these, right, the function that this looks like the most is the square root function. So when it asks you to identify the parent or base function, that would be your answer. So the base is y equals root x. And so this means that these graphs are just some kind of transformation of the root x function. And I'm going to do these using the mapping rule. For those of you that your teacher uses the mapping rule, this is what we're going to do. The first one, part A, I have y equals, and there's a plus 3 inside of the root. So that plus 3 is a horizontal translation 3 units to the left. It's inside of the function. If it's inside of the root, it's going to be a horizontal movement. Because it's a plus 3 indicates that it's going to be moved to the left. That's how you have to remember it. Plus 3 is going to the left with a plus. And then the 3 tells you how many units it's going there. And then towards the end of the function, outside of the root, at the very end, there's a -4. That's going to be a vertical translation. And that means it's going to be moved up or down. Negative numbers always mean that the graph is moved down. So it's a vertical translation, 4 units down. So now I have my two transformations, and I'm going to use the mapping rule to see what happens to the key points. When you look at the y equals root x function, remember in a previous video, we came up with these key points. And so in this video, we're going to transform these according to the mapping rule. So I have y equals root x. We're going to take these points here, which are x and y. So these points are x and y. And I'm going to get x, y like that. Map them. It says that there is a movement 3 units to the left. For you to move a number 3 units to the left from x, you have to subtract 3. And I understand. Students tell me all the time that this is a bit confusing because here it says plus 3, but here we're saying -3. And that's because a plus 3 inside of the root, this plus 3 means that it's moved 3 units to the left. But when you do the mapping rule, you have to actually move the numbers 3 units to the left. So if I'm looking at 0, I want to move 0 3 units to the left. I don't want to do 0 plus 3. That's going to move it to +3, which means 3 units to the right. So let's not do that. Let's move 0 to the left 3 by subtracting 3. 0 minus 3 is -3. And I just want to do this with all of my x's. If I give you 1 and I say move it 3 to the left, you subtract 3, you get -2. If I give you 4, I say move it 3 to the left, you subtract 3, you get the 1. I give you 9, you subtract 3, you get a 6. For the y values, okay, this is more fun. Students like it. It's going to be more intuitive. The y values are going to be moved 4 units down. So guess what? The mapping rule will say y minus 4. That's how you move a number down. So I go through each of these y's and subtract 4. 0 minus 4, 1 minus 4, 2 minus 4, 3 minus 4. There's my key points. And I'm going to plot these, and those will be the points of the new transformed function. If you're having trouble with understanding anything I may have said, you can rewind the video again and just try to follow, see if it makes more sense the second time. Never expect yourself to know everything all at once, right? So it's perfectly fine to replay if you didn't understand a part of the problem. So let's see. We've got -3 with -4. Okay, so -3 with -4, -1, -2, -3, -4. That's right there. Okay, that's -3, -4. Then I have -2 with -3, -2 with -3. And then I have 1 with -2. So x is 1, y is a -2. And then x is 6. So I go to 6. 2, 3, 4, 5, 6. 6 with a -1. And I'm going to connect these points. Now, you have to be a bit careful because it's not going to be a curve like this. You have to remember that the square root function has a starting point. So let me take you back to what a square root function looks like. It looks like that, with 0, 0 here. Think about where the 0, 0 went. That point here, that starting point. It went to -3, -4. So this will be like my new starting point. And all of the other points will be to the right of it. So like that, I connect, and I connect once more. And there's the graph. That's the graph of the function y equals root of x plus 3 minus 4. Okay, now you can pause the video, see if you can do part B by yourself, and then play it again and see if you have any thoughts. If part A didn't make sense, maybe B will make a little bit more sense. Okay, so let's look at B now. Right away, I see that inside of the root, we have x minus 1. For part A, I told you that plus 3 meant a horizontal translation 3 units to the left. So when I do B, having a -1, that's going to mean a horizontal translation. And a minus is going to mean to the right, 1 unit to the right. And then there's a plus 5. Well, in part A, a -4 towards the end of the function meant 4 units down. So plus 5 means a vertical translation, 5 units up. Okay, when we do the mapping rule, it's going to have these characteristics. So let's again look at the key points on the square root function, because that's what we're transforming after all. We're doing something to the square root function. So these are the key points. Again, if you're like, how does he know this? You can see one of the previous videos I made where I created the points on the graph of the root x function. Okay, so I take these. I want to move the x values 1 unit to the right. So I give you x. For you to move x 1 unit to the right, you do x plus 1. Okay, so I want to do that to all of these x's. 0 plus 1, 1 plus 1, 4 plus 1, 9 plus 1. There we go. The y values, we are saying there is a vertical translation 5 units up. So if I give you a bunch of numbers, y values, I say move them up 5. You would just add 5 to them. So y plus 5. So I go through all of these and I add 5 to them. 0 plus 5, 1 plus 5, 2 plus 5, 3 plus 5 is 8. Okay, and these are the new key points we will plot to do the transformations. Okay, so I'll move the y-axis down here because I can already see that there's a bunch of positive numbers. Okay, x-axis, y-axis, and let's plot these new points. 1, 5, x is 1, y value is 5. So I'm going to go up by 2s, 2, 4, 6. So 5 would be over here. 2, 6. So that would be right here. 5, 7. 3, 4, 5. 5 is with a 7. 10. So if I went all the way to 10, 6, 7, 8, 9, 10. So 10 would be here. 10 with an 8. 10 with an 8 right there. There we go. So that would be the new graph. Again, keep in mind, like I talked about in part A, you have to remember your starting point, 0, 0, 1, 2, 1, 5. So this is now your new starting point. And so the remaining points are to the right of it. And there we go.